Hello, everybody. I am Dario from the University of Bath in the UK, and today in my presentation, I will try to convince you that if you go into a rugby tackle, you don't want to have your head down or perform a low tackle because that increases the cervical spine injury risk. So the aim of my talk are, first of all, to investigate the effect of tackling technique on neck internal loading, and if possible, also identify what are the injury mechanisms during a specific type of tackle, which is, again, what we are going to talk about, which are head first misdirected tackles. So we want really to focus on tackles where the head is actually loaded during a tackle. And the approach that we are using to do so is a computational approach. So we're going to use MSK models and forward dynamic simulation in order to reproduce such injuries in a virtual environment. In terms of the simulation setup, we wanted to span a very large number of contacts. And to do so, we run more than 2,000 simulations by changing the tackle techniques in terms of the neck position. So we run simulation with 177 different neck angle conditions, changing the flexion extension, lateral bending, axial rotation. But also we did change the trunk angles for the tackler, which is the one represented by the classic OpenSim model here. And the ball carrier is represented using two spheres that are part of a contact model, which is used to replicate the same forces that are experienced during a tackle. So when those kind of spheres are penetrating into each other, force is generated. Finally, we also changed the tackler speed in order to add that as a design variable for the simulations. Let's move to the results. This is quite a busy slide, but what you can see on the y-axis is the peak values of the intervertebral joint reaction forces for C5, C4, and C4, C3 intervertebral joints. And on the x-axis, you have the flexion extension of the neck, the lateral bending, and the axial rotation. Different colors are related to the different initial position of the contact, location of the contact on the spheres. So first message is that actually neck flexion had the largest effect on neck internal loading. And that's very clear looking at the fact that lateral bending, axial rotation didn't generate any change in terms of the load, whilst if you look at the flexion extension graphs, the higher is the flexion, so the negative values here, the higher is the load. And that's very true for all the different locations there as well. But what about tackle height and its effect on neck loading? To explain you that, you're going to use a very similar graph to the one I showed you before. On the y-axis, we have joint reaction forces, the resultant, so a combination of compressive and shear forces. But in this case, rather than showing lots of points, I'm going to show you an average kind of load curve across all the vertebrae. Whilst on the x-axis, we have only one neck angle, which is flexion extension, which is unfortunately the most determinant in terms of neck loading. So starting from the most upright position, about minus 65 degrees from the neutral position, we do see a very similar story to the one that we saw before. A more flexed neck position does increase the force, the joint reaction forces. And that's true also if you move to a more upright position, so minus 70. And then the story of the pattern of the forces do change a bit if you move to very kind of low tackle like minus 75 and minus 80. In this case, this kind of maximum is moving towards a more extended position in the neck, as you can see. But when we had a look at these patterns and checked all the simulation, we did realize that some of the simulation for very low trunk angle didn't recreate an axial loading, which is what we want to recreate. And therefore, some of those values must be discarded because in those cases, the forces is applied very posteriorly. Similarly, that happened for very more upright type of tackles when the neck was very much extended. But what are, again, the take-home messages here? Well, it is important to reiterate that, again, also from this graph, we do see that head down is bad. And that's very clear for more kind of upright type of tackles, if you want. But also we do see that behavior for -75 and -80, with -75 having also a sort of plateau of very high values there. With -80, that kind of plateau is not as clear and then it's decreasing a bit, but it's important to see that when we lower the tackle height, there is an increase of the joint reaction force, the peak joint reaction forces, which is then increasing the injury risk. The final take-home message is related to the injury mechanisms. Looking at the joint kinematics and the joint loading, what we saw is that most of the simulation when an axial load was recreated, regardless the type of trunk angle, was a buckling type of mechanism. That kind of buckling mechanism is characterized by the fact that part of the cervical spine is flexed, usually the lower one, when we're talking about first order buckling, and other part of the spine is extended. Great, so in my presentation, I gave you 3 main take-home messages. The first one, that neck flexion is bad, which is something that is also taught by rugby coaches to the players. And that's related to the fact that they want to keep the head up for visibility purposes, but also we did show that a head down position will increase the neck loading, so you want to try to avoid it. The second one is that also a lower trunk position could be more dangerous because that's related to higher neck internal forces. And also we saw that the alignment between the force, the head, neck, and trunk kind of complex is fundamental there because that will change depending on the trunk height. But surely we also saw that the peak values for the lower trunk tackles were greater. Finally, if we're talking about head first misdirected tackles, we did see that buckling was the most likely injury mechanisms as we saw in that video. Many thanks. Bye-bye.